whose chemical structure has a central metal atom surrounded by non-metal atoms or groups of atoms known as ligands. All the ligands surrounding the central coordination compounds are the class of substances whose chemical structure has a central metal atom surrounded by non-metal atoms or groups of atoms known as ligands. All the ligands surrounding the central ion need not be the same, because ligands remain in fixed position around the central atom or ion. Different isomers or arrangements of the ligand groups are possible. Because of the different arrangements of ligands, the isomers differ in one or more physical or chemical properties. Among coordination compounds, there are two principal types of isomerism: stereoisomerism and structural isomerism. Stereoisomers have the same chemical formula and chemical bonds but differ in the relative orientation of these bonds. Stereoisomers are further classified as geometrical isomers and optical isomers. Geometric isomerism arises due to the different possible geometric arrangements of the ligands. For example, consider a coordination compound Ma2B2, where M is a metal and A and B are ligands. The two ligands A may be arranged adjacent to each other in cis isomer, or the ligands may be arranged opposite to each other in trans isomer. In octahedral complex having the general formula Ma2B4, the possible isomers are as shown. In octahedral coordination entities of the type Ma3B3, the possible geometric isomers are facial and meridional. The second type of stereoisomerism is optical isomerism. Optical isomers are mirror images that cannot be superimposed on one another. These are called as enantiomer. One isomer rotates the plane of polarized light to the left, the other rotates the polarized light to the right. The compounds are said to be chiral and optically active. The second principal type of isomerism is structural isomerism. Structural isomers have different bonds. The different type of structural isomerisms are linkage isomerism, coordination isomerism, ionization isomerism, and solvate isomerism. Linkage isomerism occurs with ambidendate ligands, which can bind in more than one place. For example, NO2 is an ambidendate ligand. It can bind to a metal at either the N atom or an O atom. Coordination isomerism arises when compounds containing complex anionic and cationic part interchange some ligands from the cationic part to the anionic part. For example, these are the two isomers. Ionization isomerism arises when the counter ion in a complex salt is itself a potential ligand. It can displace a ligand which can then become the counter ion. The possible isomers are: solvate isomerism is similar to ionization isomerism. Solvate isomerism differs by whether or not a solvate molecule is directly bonded to the metal ion or merely present as free solvent molecules in the crystal lattice. For example, these are the two solvate isomers.